Lesson 6, Unit Rates from Graphs. Hopefully you'll remember some of this from last semester. So just kind of to recall real quick, what is a unit rate? So a unit rate is going to be any fraction with a 1 in the denominator. Okay, so that means that an example could be something like 6 over 1 or 60 miles per 1 hour, something like that. Also remember that to find unit rate, we write our coordinate pair as y over x, okay? So say I was given something like, I don't know, 2 comma 1. When I write y over x, remember it's x comma y, so I would have 1 over 2, which this isn't quite a unit rate yet. I could simplify it to have a 1 and then a 1/2 up top. So remember, it's always y over x. The next thing I want you guys to try and think of that we talked about before is constant of proportionality. This is also known as k. Okay, remember the formula y equals k times x. K is another way of saying your unit rate. Okay, so your unit rate can also be K. So say you have a question and it's like write a formula knowing with the unit rate of 6. Now I want to write a formula. I would have y is equal to 6 times x. Okay, so when you're writing your formula, you should only have one number and it should be next to your x. Alright, first thing, let's start practicing. So we want to figure out what is the unit rate from this graph that we have here. So when you're trying to figure out unit rates, you are looking for, if you can, remember you have y over x, and with a unit rate, you always want your denominator to be a 1. So if I look down here at my x-axis, if I go over to where x is 1, because that's what I want, right? I want a 1 in the bottom. If I follow 1 up, I stop at this point right here on my graph, okay? And if I bring that to the side, it tells me that it's 3, which means that this coordinate pair here is 1 comma 3. So when I write my y over x, I would have 3 over 1. So my unit rate here is $3 for every 1 gallon. And I know that because it tells me my y is cost in dollars and my x is in gallons. We also want to know, what does 0, 0 mean on this graph? Well, if I'm at 0, 0, right, that means that I haven't put in any gas into my car or whatever you're putting gas in. So it means I haven't spent any money, right? So this means you have spent $0 for 0 gallons of gas, which makes sense because if you don't buy any gas, you're not spending any money because you're not purchasing it. We want to know, how much would you spend for 9 gallons of gas? So now we're talking about 9 gallons of gas. Well, if I look here at the bottom, 9's all the way over here. Okay, so if I were to take this line and extend it, okay, and I follow 9 all the way up, it's going to cross right here. And if I follow this point all the way this way to tell me how much it would cost, it should cost $27. There's one other way you could do this, which is setting up a proportion. My unit rate is $3 for every 1 gallon. If I know I am buying 9 gallons of gas, to go from 1 to 9, I can multiply 1 by 9. So I'm going to do the same exact thing to the top. So 3 times 9 is going to give me 27. So there's a few different ways you could go about this problem. Alright, next one. Same type of questions. Remember, x, I'm looking for a 1. Okay, so here's my 1 for my unit rate. If I follow this up and across, it tells me at 0.5 I will have a denominator of 1. And it says here for my y-axis, again it's in dollars, so I'm spending 50 cents for every 1 pound. Okay, so that is my unit rate. The next question is asking us how much, or I guess this should be what does 3 comma 1.5 represent based off this graph. So 3, let me do a different color. Oops, green. So when I'm at 3, right, and I go all the way this way, I get to 1.5. So that means that when I buy 3 pounds, so 3 pounds, whenever I buy 3 pounds, like let's say this is apples, I will spend $1.5. Now $1.5 is close, but usually when we're talking about money, we have 2 decimals after, right? So instead of having 1.5, if I had a 0 after, now that looks like $1.50, right? So for every 3 pounds of whatever I'm buying, I spend $1.50. And again, we have this other question that says, what does 0, 0 represent on the graph? Right, well, if I'm at 0, 0, I haven't bought anything, so I'm not spending any money. So 0, 0 represents, it's kind of like I haven't bought any apples, so I'm not paying for any. So for this one, we could say something similar to what we said on the other example, along the lines of, I spend $0 and get 0 pounds of whatever I'm buying. I like to think it's apples. Next one. So if you pay $16 for renting a bike, how many hours did you rent your bike? Okay, the first thing here we have to look at is what the numbers on our y-axis and our x-axis represent. So if I look at my y-axis, which is always up and down, it's represented by dollars, and x is going to be represented by number of hours. Okay, so if I spend $16, I'm going to go where 16 is on this tick mark, and I'm going to draw a line all the way until I touch my line. Right here is where 16 touches my graph, and then I'm going to go straight down, and it tells me that I rented a bike for 4 hours. So after 4 hours of renting my bike, I spent $16. Next one is slightly the same but a little bit different. So we want to know how much money Jamie would get if he works for 5 hours. So again, the question is asking me about 5 hours. Right? So do I want to look at these numbers on my y-axis talking about money, or do I want to look at the numbers on my x-axis talking about hours? Well, I know that he worked 5 hours, right? So I'm going to use this number down here as my starting point, and I'm going to go from here all the way up till I hit my graph. And then from that point, I'm going to go all the way over on that same line. And it tells me that he should get $40. So he should get $40 after working 5 hours. Alright, next one. So this one is a little bit tricky, but it's actually not too bad if you know what to look for and how to start. We want to know which of these equations describe the relationship between S and G. So S represents the amount of sand and G represents the amount of gravel used in the mixture, and we want to select 2 that apply. So your X down here is going to be G, and your Y over here is going to be S. Okay, and what I think is easiest to do here is follow your graph and stop when you get to a point where your graph crosses your grid lines in the center of an intersection. So right here you can see that my line passes through these grid lines directly in between them. Okay, so what I'm going to do is I'm going to use these 2 points. Okay, so I have 3, 9. Now remember that instead of writing X and Y here, instead I'm going to write G for X because I'm talking about the amount of gravel, and I'm going to write S for Y because my y-axis is talking about the amount of sand. So what this is telling me here, if I were to write this in words, is that for every 3 pounds of gravel, I should get, I have 9 pounds of sand. Okay, so for every 3 pounds of gravel, I have 9 pounds of sand. Now what we're going to do with these two numbers is we're going to take 3 and plug it in wherever we see a G, and 9 and plug it in wherever we see an S. So starting with this first equation here, S equals 3 times G. So remember, S is 9, G is 3. So I have 9 equal to 3 times 3. So if I were to simplify both sides of these equations, I have 9 is equal to 9. Does 9 equal 9? Yes, which means this one works. This is a duplicate, so ignore this one on the bottom. Let's try this next one here. So the second equation I have is G equal to 3 times S. Remember, G is 3, and this is equal to 3 times 9. Well, is 3 equal to 27? Are those the same two numbers? No, right? Which means this one, it cannot be. Then let's try this very bottom one. So I'm going to rewrite this one over here. S over 3 equals G. So S is 9. I'm going to have 9 divided by 3 equals 3. 3 does equal 3, which means that this one also works. So those two equations are correct based off of this graph. Alright, next one wants us to write an equation that represents the relationship between P and A. So notice that my X on the bottom is my population, so that is P, and my number of accidents is going to be A, which is my Y. Remember that whenever you're asked to write an equation, you want to use Y equals K times X, where K is your unit rate. So the first thing we need to do here is figure out what our unit rate is. And it gives us these points which we're going to use to determine that. So this first point right here, whoops, let's find our X and Y coordinates. So our X is going to be 1,000. And if I bring this all the way over here, there's no number, so we have to figure out what this number would be. If I'm going from 0, blank, 6, right, each of these has to be an equal distance. So I'm going 0, 3, 6, 9, 12, 15. I'm counting by 3, so each one of these tick marks is represented by a 3, which means my Y coordinate is going to be 9. So when I write my unit rates, I'm going to write this as Y over X, which is going to be 9 over 1,000. Okay? And remember, we want to have a 1 in the denominator, which means we need to divide 1,000 by 1,000, which means we need to do the same exact thing to the top. So if you don't know what 9 divided by 1,000 is, you can type that into a calculator, or you can move your decimal that is right here, and you can move it 3 times this way to have 9 thousandths. So that tells me that my unit rate, or K, is 0.009. So remember that when you're writing your equation, the only thing that's changing is you're taking this number right here and plugging it in for K. Okay, so I'm going to have Y is equal to 0.009x. However, notice the question says, well, I'm talking about population for X, so I'm going to put a P here, and my A is number of accidents, so I'm going to put an A here. So this right here is going to be our final equation. And the second question is asking us, what does the point 1,000, 9 represent based off the graph? So when we look at our 1,000, that is talking about population, right? So this means that there's 1,000 people that we're talking about. And out of those 1,000 people, 9 of them were in an accident. So this means that out of 1,000 people, 9 were in an accident. So for these problems, it's super important to make sure that you are looking at what your axes are labeled as. So number of accidents would be that 9, and 1,000 is the population. Okay. All right. So checkpoint 6 does have some tricky questions. So if you do need help, please join me in one of my open sessions. They are on Monday through Thursday from 11 a.m. to 1 p.m. Other than that, let me know if you have any other questions. Email me, message me, and I hope you have a wonderful rest of your day. Thank you.